Hello, I want to find the limit of the sequence an is equals to 2n all over n plus 4n raised per half and prove that it is a convergent sequence. Now, this is very easy. You just need to be very careful in the way we handle it. Okay? Now, let's guess the limit of this sequence. How do we guess? Fine. Let's say that, the sequence is an is 2n all over n plus 4n raised per half. Let's divide through by n. So by the time we divide through by n, we are going to have this. Okay? So this will cancel this out. This will cancel this out. And this one divided by n as well. We divide everything by n. We're going to have 2 all over 1 plus. This will be what? 4 all over n raised per half. Yes, because by the time, it's going to be n raised per half minus 1. So that is 4 all over n raised per half. Beautiful. Now, in this case, we observe that we can have this as n tends to infinity. That is, in this case, if we take our n to tends to infinity, that is, take limits of this particular value now, 2 all over 1 plus 4, you can write this 4 all over n raised per half as n tends to, that is, if n becomes very large, and large, so this will be what? 2 all over 1 plus 0. Okay? And this one will go 2 over 1, which is equals to 2. So we guess that the limit of this sequence is 2. Let's just guess. Okay, now with this guess, we want to find out whether our guess is right or not. Okay, let's try to find out whether our guess is right or not. Now let's do this. Okay, in the course of trying to do that, we want to prove that the sequence an is convergent. And we know that for sequence an to be convergent, given epsilon greater than 0, there exists a natural number, let's say m is a natural number such that, the absolute value of an minus, let's say the limits in question is L, bounded by epsilon, whenever n is greater than or equals to m. Okay? Don't forget our limits there is L. So given epsilon greater than 0, there exists a natural number m such that, the real number there is the L, which is the limit. So which, by the time we substitute here, we have this. The sequence itself is, that is, we have 2n all over n plus 4n raised per half, then minus. Now our limit, what we obtain is 2 bounded by epsilon. Okay, so that means we compute now. Find the LCM. The LCM is m plus 4n raised per half. Then there is over 1 here. So the whole of this here, we must have 2n. Okay, then minus 1 in the whole of this is this times this. That's 2. Let's say 2 into bracket n plus 4n raised per half. All right. Okay. So we have 2n minus 2n, then minus 8n raised per half, everything all over n plus 4n raised per half. Okay. Now let's clean this so that we're able to have enough space for the calculation. Okay, since we have taken absolute value and 2 minus 2 is cancelled, so we have what? We have absolute value of minus 8n raised per half, okay, all over n plus 4n raised per half. So this will be what? Because absolute value of negative sign is positive. So 8n raised per half all over n plus 4n raised per half. Now don't forget, it's less than epsilon. Whenever n is greater than or equals to m. Now, in this case, this particular, if as our n becomes very large and large and large, you know, we can truncate this. We can remove this 4n raised per half, because the whole of this, if we put it there, we want a value that will be less than. Okay, what I'm saying is this. We want a value, so that is, we can say that this one will be 8n raised per half all over n plus 4n raised per half will be less, less or equal to 8n raised per half all over n. Yes, the whole of this value will be less than this. Because as big as this, it will reduce this. So this will be less than this. Okay, now less than what? Epsilon. Now with this condition, whenever n is greater than or equals to m, so this one now becomes what? Let me clean this so that I'll be able to have enough space now. So this one will now become 8m raised per half all over m less than epsilon. Okay, so how do we now get this? We can have this as, our m here, we can have it as, okay, we can now say that cross multiplying, we have 8m raised per half less than m of epsilon. Okay, I think we are getting that. Okay, so if we divide through by m, let's say we divide through by m, ordinarily we can even do that here. We can say that, okay, I think it will be pretty better here. Now wasting our time, we have m in that we have 8m raised per minus half with this, okay, less than epsilon. Beautiful. So which means we have 8, times 1 over, it's like 1 over m raised per half. I hope you get that. All right. So I'm trying to explain it, in such a way that you understand clearly. That's why I'm taking it step by step. 8 all over m raised per half, okay, less than epsilon. So by the time we cross multiply here, because our target now is to get m, and to get m, we will need to square both sides. So I'll not waste our time. Let's square both sides in order to get m. Okay, yes. Squaring both sides now, you have 8 squared all over m raised per half squared. I hope you are getting what we're doing here. Less than epsilon squared. Yes. So the square on m will disappear now. So you have what? 64 all over m is less than epsilon squared. So which implies 64 is less than m epsilon squared. So by the time you have m epsilon squared greater than 64. So m will be greater than 64 all over epsilon squared. So this is the value of m that we need for that particular condition to hold. And luckily enough, this is a positive value. So in this case now, since we have obtained a positive value, for our m, that now implies, so we can now conclude, since m is positive, you can say since m is positive, then the condition an minus L is bounded by epsilon holds whenever m is greater than 64 all over epsilon squared. So with this, we have proved that the sequence an is a convergent sequence. Thank you very much. God bless you.